D block elements is the collective name for the groups 3 to 12, in which the d orbitals are progressively filled in each of the 4 long periods. As the d block elements lie between the s and p block elements, they are also referred to as the transition elements. The f block elements, on the other hand, include the 4f and 5f series of elements, in which the 4f and 5f orbitals are progressively filled. They are often referred to as the inner transition metals because they involve the filling of the inner 4f or 5f subshells. There are mainly 3 series of transition elements. They are the 3D series, the 4D series, and the 5D series. The 4th series, the 6D series, which begins with actinium, is still incomplete. The first transition series includes the elements from scandium to zinc. The second transition series includes the elements from yttrium to cadmium. While the third transition series includes the elements from lanthanum to mercury. By definition, transition elements are those that have incompletely filled d orbitals either in their elemental state or in any one of their chemically significant oxidation states. Thus, the elements zinc, cadmium, and mercury, which have D10 configuration, both in their elemental and in their stable oxidation states, are not considered transition elements. The general electronic configuration of these elements is N-1 D1 to 10 Ns1 to 2. This generalization has several exceptions, because the energy difference between the Ns and N-1 d orbitals is less, and the transition of electrons between Ns and N-1 d takes place readily. Furthermore, atoms of the d block elements try to fill their available d orbitals either partially with 5 electrons or completely with 10 electrons whenever possible. This is due to the fact that half-filled or completely filled orbitals impart greater stability to an atom because of the greater exchange energy. A consequence of this factor can be seen in the electronic configurations of chromium and copper in the 3D series. Chromium, for example, has a configuration of 3d5 4s1 instead of the expected 3d4 4s2. Copper, on the other hand, has an electronic configuration of 3d10 4s1 instead of 3d9 4s2. The properties of transition elements depend largely on their electronic configurations. Thus, with partly filled d orbitals, these elements exhibit certain characteristic properties, like display of a variety of oxidation states, catalytic properties, alloy forming ability, complex forming ability, formation of colored hydrated ions, and salts, and para and ferromagnetic properties. The precious metals like gold, platinum, and silver, and industrially important metals like iron, copper, and titanium form part of the transition elements.